Welcome to Spring LIB.
In this exercise, you're going to need the concept of polar coordinates. So before actually solving the exercise, I'm going to review the concept. Consider that we have here a Cartesian coordinate system, y, x, and we want to express the coordinates of a certain point, let's say this point here in black, in polar coordinates. What should we do? Well, polar coordinates r and theta are defined such that the coordinates of this point are, first of all, r, the letter r, represents the distance between the origin and the point in question. So this here is r. And the angle that the line that connects the origin to the point makes with the horizontal is the coordinate theta. So this is the polar coordinate. So r is equal to the square root of x squared plus y squared, and theta is such that the tangent of theta is y divided by x. So the position vector of a particle, this r vector here, can be written as the r coordinate times a unit vector in the r direction. Okay, and you can differentiate this equation 2 times in order to obtain that the acceleration of this particle is equal to the second derivative of r, so r with these two dots on the top, minus r theta dot squared in the r direction, plus r theta 2 dots plus 2r dot theta dot in the theta directions. Now, I've already said what is the r direction, so we need to find out what is this theta direction here. Well, the r direction, as I said, is the unit vector that points in the direction of the point we're interested in, and the theta direction points in this direction here, perpendicularly to the r unit vector. So this here is the theta unit vector. Okay, and we can obtain this equation for the acceleration of the particle by using the fact that the unit vector changes with time. So r, the derivative of r hat, is equal to theta point times theta hat, while theta hat, the derivative of theta hat, is minus theta point r hat. Okay, so this here is the equation we're going to use. Okay, so what we have in the exercise is that we have a particle that undergoes a certain trajectory with values of the coordinates r and theta that are r equals 2t plus 10 in meters, while theta is equal to 1.5 t squared minus 6t. This is in radians, and t is in seconds. And the mass of the particle is 5 kilograms. And our goal is to find what is the total force that acts on the particle, the magnitude of the force, actually. So what we need to do is to remember that the force is equal to the mass times the acceleration. Okay, and we know that the acceleration vector is equal to, as I said before, r 2 points minus r theta point squared r plus r theta 2 points plus 2r point theta hat. Now, notice that what we want to do here, what the exercise asks us, is the force when the time t is equal to 2 seconds. Okay, so I'm going to calculate both. I'm going to calculate r point, and r 2 points and also theta, theta point, and theta 2 points when t is equal to seconds. Okay, so when r for t equals 2 seconds is equal to 14, our point is the derivative of r, that's just 2. So regardless of the time, our point is equal to 2. And our 2 points is equal to 0 because our point is a constant. Also, theta is equal to, theta of 2 is equal to minus 6. Theta point of t is equal to 3t minus 6. So at t equals 2, this is equal to 0. And theta 2 points of t is equal to 3. So this does not depend on time. So we have that the acceleration a is equal to 0 in the r direction, because we have 0 minus 0, plus r times theta point, 2 points, I'm sorry. So that is 14 times 3 plus 2 r point, so that's 2 times theta point, that's 0. So we have that the acceleration is equal to 42 theta hat. Okay, and are going to find the force. So the magnitude of the acceleration is 42 meters per second squared. So the force is equal to 5 kilograms, that's the mass of the particle, times 42 meters per second squared, which is equal to 210 newtons, which concludes our exercise.